Welcome to today's lesson. Our lesson target is I can find the slope of the hypotenuses of similar triangles. To prove the triangles are similar, our essential question reads, what are the different ways we can find the slope of 2 points? So to remind us, the slope is our unit rate of change. And hypotenuses is a new vocabulary word, so we'll get to that word in a second. Similar triangles, if you think back to when we started the school year, we were talking about similar figures or similar shapes when we were on our geometry unit. So similar triangles are the same shape, just different sizes. So usually we're talking about a big triangle and then a small triangle. Okay, so then to answer the essential question, what are the different ways we can find the slope of 2 points? Well, we have to remember that slope can be represented with the letter m. And the equation for m is y2 minus y1 over x2 minus x1. So that's for non-proportional relationships. For proportional relationships, we use the letter k to represent that unit rate. And so we find our k by dividing our y divided by our x. So if we look at the two equations for m and for k, we're going to see that on top we have our change in y, and then on bottom we have our change in x. And our change in y, if we remember the y-axis, is our rise because we are going up or down. And then our change in x is called our run because we're either going right or to the left. So we're going to go into our vocabulary so that we can further understand what is a hypotenuse and why are we finding the slope of the hypotenuse. Okay, so our vocabulary words are familiar. Slope, as you guys can see, it says a slope is a number that describes both the direction and the steepness of the line. So we talked about that up, down, left, right. And steepness is like how high or how if a line is closer to being horizontal, that means it's not steep at all. If a line is close to being vertical, that means it's pretty steep. Okay, so then we have a right triangle. So a right triangle is a triangle with a right angle, 90 degrees, or where two sides are perpendicular. So remember that perpendicular means two lines that meet at a 90-degree angle, right? So that's why we have a 90-degree angle in this corner right here. So we have these two triangles. We have the yellow one and then the green one, of course. And we can see that they are similar because, again, we talked about this as we read the lesson target. Similar triangles are the same shape, different sizes. So as you can see, our next vocabulary word is similar triangles. So similar triangles are triangles, again, that have the same shape but different sizes. Hypotenuse, this is important. It's our new vocabulary word. The hypotenuse is the longest side of a right triangle. That side is opposite the right angle, right? So it's opposite this angle right here. Another way to think about it is I'm going to go ahead and label the sides A, B, and C. So the hypotenuse would be this C right here. And then I'm going to do that again for this bigger triangle, A, B, C, but now lowercase letters. And so again, the hypotenuse is this C right here. So uppercase C and lowercase c are corresponding sides. If we think back to sides that are in the same position on similar shapes, right? And we can see that they're the longest side of a right triangle. And then we have uppercase A and lowercase a are corresponding sides. Uppercase B, lowercase b are corresponding sides. Okay, so also something to note is that you can see that the hypotenuses are all on this line right here, right? This linear equation. So this is how it all connects to what we've been learning about with non-proportional linear equations. Okay, next we have the word coordinates. Coordinates are two numbers, x, y, that locate a point on a graph, also known as the coordinate plane. Then we have our change in y, which is the difference between the y coordinates of 2 points. So we talked about that earlier. That's our y2 minus y1. We can also represent that by using a delta symbol and the y. And so in our picture or in our graph, we can see that a, uppercase a and lowercase a, represent our change in y. And another way we can double check that is we can see that this line right here for A is parallel to this y-axis right here. That's how we know that that is our change in y. And then we have our change in x, which is going to be our lowercase b and uppercase b. So we have our change in x. And another way that we can verify that is, of course, using that this b is parallel to this x-axis. Okay, so our change in x is the difference between the x-coordinates of 2 points. So that's our x2 minus our x1, and that can be represented by delta x. We're going to skip over our activity and go straight into our redo. So this redo reads, find the slope of the hypotenuse of the right triangles to verify that the triangles are similar. We already talked about the word slope, hypotenuse, and similar. And as a reminder, the word verify means to check or confirm. So we're confirming that the triangles are similar by finding the slopes of the hypotenuses. Okay, this problem reads triangle HJK and triangle KMP are similar right triangles. The coordinates of the vertices are integers. Determine if the slopes of line segments HK and PK are congruent. Okay, so it already tells us slope of HK, which as you can see is the bigger hypotenuse right here. It's the hypotenuse of the pink triangle. And then we have to find the slope of PK, which is the smaller triangle or the purple triangle. And if we wanted to, we can go ahead and label our change in Y, change in X, change in Y, change in X, right? Just to make it easier for us to understand and see. And we know that to find the slope of HK, to find our change in Y, we have to count or find the distance between HJ, which is this side right here, and then, of course, JK, which is this side right here. So even if you switch the letters, so HJ is the same thing as JH, or JK is the same thing as KJ. And then for our slope of PK, our change in Y is MK, as you can see right here. And then our slope change in X is PM, which again, you guys can flip around the letters. Okay, so I'm gonna count from H to J how many units or how many boxes are in between. So I noticed that in class, a lot of people messed up on this. So I'm gonna do this example with you guys. So this is the first box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that means our change in Y is 10. And it's going to be negative 10 because we went down from left to right. So this is negative 10. Then our change in X, I'm going to go ahead and count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12. So we have negative 10 over 12. Okay, so we have our slope as a fraction, and I want to simplify it. I want to put it in simplest form. So to do that, I'm going to go ahead and list out the factors of 10 and 12. So the factors of 10 are 5 times 2. The factors of 12 are 3 times 4, but 4 can be broken down into 2 times 2. So now I'm going to cross out the common number, the number that's the same on top and bottom, so that's the 2. And then that means that negative 10 over 12 is the same thing as 5 over 3 times 2 is 6, 5 over 6. But because our slope was negative, I have to remember to add the negative sign back in. So we have negative 10 over 12 is equivalent to negative 5 over 6. Okay, so that was the slope for that bigger pink triangle. And then we're doing the slope of the smaller purple triangle, right? So we're finding the side length of MK. So MK is going to be negative 5. So again, all we had to do was count the boxes in between M and K. And then our change in X, which is PM, is going to be 6. So we have negative 5 over 6. And we know that negative 5 over 6 is already in simplest form. So as you can see, the slopes of the hypotenuses of similar triangles are the same. They are congruent. They are equal. I'm going to say that one more time because that is one of the main points of today's lesson. The slopes of the hypotenuses of similar triangles are the same. They are congruent. They're equal. So something that I noticed that people messed up on in class is the math, right? The simplifying, the negative 10 over 12. So I'm going to remind us how we can find that on Desmos. So I'm going to type in negative 10 divided by 12. And you can see that automatically it turns it into a decimal. But to turn it into a fraction, I just have to click on the left where it has that little fraction inside the circle. And you can see that it turns it into negative 5 over 6, right? So it already simplifies it for us. And let's say we didn't know that negative 5 over 6 was already in simplest form. So I'm going to go ahead and try that. Negative 5 divided by 6. And you can see that again, it turns it first into a decimal. But if we click on that fraction symbol on the left side, you can see that it turns it back into a fraction. -5/6. So that's how you can double check or confirm, verify that a fraction or of, the slope is in simplest form. Okay, so our next problem relates to that main point that I just repeated, right? That the hypotenuses or the slope of the hypotenuses of similar triangles are the same. So it's just a word problem. It reads triangle HJK and triangle PMK are similar right triangles. The coordinates of all the vertices of integers are integers. Which statement is true about the slope of line segment HK and the slope of line segment PK, right? So we're talking about HK and then we're talking about PK. So remember that PK can be called KP. Okay, so I know that the slope of the hypotenuses of the similar right triangles are equal, right? So they are equal. Another word for that is congruent. Another word for that is the same. So now I'm looking for an answer choice that says that. Okay, so answer choice A says the slope of line segment HK is less than the slope of line segment PK because the ratio of the change in Y values of the endpoints, the change in X values of the endpoints is less for HK than it is for PK. So I know that's not true because we just said they're the same. Okay, B says the slope of line segment HK is equal to the slope of line segment PK because the ratio of the change in Y values of the endpoints to the change in X values of the endpoints is the same for HK as it is for PK. That is true. So our answer is B. Just to confirm, I'm going to read C and D really quickly, just, to eliminate those answer choices. We have the slope of line segment HK is greater than the slope of line segment PK because the ratio of the change in Y values of the endpoints to the change in X values of the endpoints is greater for HK than it is for PK. We know that's not true. We know it's not greater. And lastly, for D, it says the relationship between the slope of line segment HK and the slope of line segment PK cannot be determined because the triangles are congruent. So yes, the triangles look congruent, but the slope can be determined, right? So that's why it wasn't D. Okay, so then our last we do that we're going to do together reads triangle HJK and triangle KMP are similar right triangles. The coordinates of the vertices are integers. Determine if the slopes of line segment HK and PK are congruent. So again, we have to find the slope of HK, slope of PK. Okay, so from here, I'm going to go ahead and highlight HK and PK. And as you can see, they're all on the same line, right? That same linear relationship, that same linear equation. Anyways, I'm going to go into labeling my triangles, my change in Y, change in X, change in Y, change in X. And I know that my change in Y, for the triangle that has the HK as the hypotenuse, to find that I have to find my distance from H to J. Right, and to find my change in X, I have to find the distance from J to K. Okay, then for slope of PK, right, for my purple triangle at the bottom right here, for that hypotenuse, to find my change in Y, I have to find the length of KM on top, my change in Y, over my change in X, which is MP. Okay, from here, I'm going to go ahead and count the boxes, right? So we have 8 boxes for my change in Y. For H to J is 8, so we have -8 on top. And then our change in X is going to be 6. So we have -8/6. So I know -8/6 is not in simplest form, so of course I'm going to have to simplify that. So then we have the factors of 8 are 4 times 2, but we know that 4 can be broken down into 2 times 2. The factors of 6 are 3 times 2. Now I'm going to cross out the number that is the same on top and bottom. So we have the 2 that's the same. Okay, so now I'm going to go back to writing what my answer is in simplest form. So 2 times 2 is 4, and then we're left with 3 on bottom. And because our answer or our slope was originally negative, then we have -4/3 is our slope of HK. So to find our slope of PK, we have to find the length of KM. So KM is also -8. And then MP is also 6. So it looks like in this case, these triangles are congruent, right? But we also have already simplified negative 8 over 6. So I know it's not in simplest form. If we look on the left, we got it simplified to negative 4 over 3. So that's how we just proved that the slopes of HK, PK, which are called the hypotenuses of the right triangles, are the same, right? They're both negative 4 over 3. The rest of the lesson is you-dos and independent practices. Thank you so much for following along in today's lesson, and see you in the next one.